Alright, taking a look at some logs here. The very first thing we take a look at here is just a general form of writing a log. Log base b of y equals x. If I want to write that then as its equivalent exponential, I have my b as my base. My exponent is this number right here. So solving for an exponential or an exponent gives you a log problem. So when I switch it back to the exponential, whatever the log equals is my exponent. And that will then equal y. So these are equivalent expressions right here, or equations I should say. Second thing we can take a look at here is now what if I have some values. So I have 2 to the x equals 1 over 16. So what value of x is going to make that my base of 2 equal 1 over 16? Well, I know that 2 to the 4th equals 16, and to make it into a fraction, I could have it as 2 to the negative 4th would equal 1 over 2 to the positive 4th, which is 1 over 16. So x equals a negative 4. Now if we have a problem like this, log base 5 of 23 equals x. Again, if I wrote this as 5 to the x equals 23, wrote it now as my exponential, I can now try solving this. Alright, so here's what we need to do with logs. I can take the log of both sides here. So I could take the log of 5 to the x equals log of 23. My exponent here gets moved out in front, so I will now have x times the log of 5 equal the log of 23. And to solve for x, I just divide both sides by log of 5. This becomes a giant 1. They reduce down to 1. So x will equal the log of 23 divided by the log of 5. And that gives us 1.948 approximately. Alright, a little bit more difficult of a problem here. First thing what I want to do is I need to get this base and exponent by itself. So to do that, I add 6 to both sides, giving me this. I'm going to then divide both sides by 2. I get 34 equals 4 to the x minus 1. From here I can use my logs because now I have my base and exponent by itself. So I'll take the log of both sides, and remember that the x minus 1 goes out in front. Divide both sides by log of 4, and now I have x minus 1 by itself because that becomes a giant 1. Solving for x, I add 1 to both sides and I get 3.544. The last thing to go over are different properties that we have. The top one we have here is the product property. So log of a plus log of b is going to equal the log of a times b. And the bottom one we have log of a minus log of b equals log of a divided by b. So examples of that would be if you had log of 3 plus log of 5, that is going to end up equaling log of 15 because 3 times 5 equals 15. Using the quotient rule in the bottom, log of 12 minus log of 3 would equal log of 12 over 3, which is log of 4.